I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a worksheet on Venn diagrams. Many students have requested for the same. I am going to adopt an excellent approach using De Morgan's theorem to simplify complements of events that will help you to effectively answer questions related to Venn diagram and put you on success highway. Practice and learn. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Now, let us enjoy the Venn diagrams and master the skills. Let us try to understand Venn diagrams in very simple language. Here is a worksheet for you. I'll share some questions. You can always pause the video, answer these questions, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Also, check our website, Global Math Institute, for new updates. As you can see, we have many questions related to Venn diagrams. We'll begin with very simple ones, where you have to just shade in what do A represents in the given Venn diagram. So we are taking two events at the same time. So we have two events. So one event is A and the other event is B. We'll look into different combinations of these events using the concept of complements. So when I say A bar, it means not A. Complement of A, and the symbols which we are using here. U means or union. This symbol is for and or intersection. Is that clear to you? So we have different operations, as you can see. So you need to shade the given Venn diagrams as per the instructions on the top. For example, if I'm looking for an event A, A means the one circle shown in red. So that is how we are going to shade in A. Is that clear to you? If I want to shade A intersection B, then it means both A and B, common to both, right? So in that case, the intersection will be the portion which is now being shaded. Is that clear to you? Now let's also look into complement of B. Complement of B means not B. Not B means everything which is outside of B. So if I have to shade that, How will I do it? Well, B is within the green circle. So outside B is like this, as I'm shading now. Is this clear to you? So that is the basics of this particular worksheet. I hope you are familiar with this. Now, based on these three examples, I will like you to copy the given figures, and then one by one, you should shade the required portion in the Venn diagrams. Venn diagrams are very useful in sorting and also in answering probability related questions. So this simple exercise, which is good for middle school and high school students, can help you in higher level of mathematics. And that is why it is very important. So I hope you have done these few. If you have, then you can move on and do more. I'm going to share with you many such questions in this particular video. So here is the very first page, which gives you a couple of Venn diagrams, and then we'll have slightly more difficult ones where we will also look into complement of complement. As you can see here, another set of 12 questions for you. Once you're done with these sets of 12 questions, then we'll also take up examples where we will have three events. You can practice what happens when we take three events at the same time. I'll also explain you a concept, De Morgan's law. De Morgan's law actually helps us to simplify and shade the events which you are looking at. I'm using a simple language in the Venn diagrams. You get the idea. So that is De Morgan's law, and a very good question for you. So that is what we are going to do today in this particular exercise. I will once again request you to copy these figures, draw the Venn diagrams, and answer the questions. Now let's begin solving them one by one. So let's do B, which is, we have to just shade it. What is B, right? So, well, B, as you can see, is within the green circle. So I'm just shading the green circle in, and that is what this event is. So that's a beginning. So you understand A is within the A circle, B is within the B circle, not B is excluding B, and intersection of A and B is common to both. That is what we mean when we say AND operation. Union, as now you get very easily, is what? Well, union will be combination of both, included in both A and B. So we are going to shade both A and B to make it union, as I am doing just now. Is that clear to you? So that is how union of A and B will be done. Now we come to many exercises where the complement of one of the events means not A, intersection B. So that is very interesting. So what does that mean? Let's try to understand. It means what? It means not A, intersection B. That means outside A, but within B. You get the idea. So outside A is everything outside A, not A. So within B will be this particular portion which I am shading now. Is that clear to you? So that is not A intersection B. Perfect. So now we'll look into not A union B. Means outside A and B, right? So, or B, right? So this means not A or. So union means or, right? So B is included anyway, right? So in this case, it is better to think like this. Well, or B means B is of course there. So I'll shade B first. Do you see that? I have shaded B. B is included and not A means everything outside of A, right? So I'm shading it in different colors so that you understand that or means included in both, right? So not so everything is being shaded here, as you can see, except for the region which is within A and not in B. You get the idea, right? So that is how we can actually do complement of A union B. Is that clear to you? Correct? So sometimes it becomes helpful to actually name the regions and then describe them. So we'll do that part also. So now let us continue and shade the other Venn diagrams. Let us do what is union of not A and not B. So outside A and outside B union. So that is what we are interested in figuring out. How do we get to this answer? I would like you to share with you at this stage De Morgan's theorem. So De Morgan's theorem tells us that we could actually simplify our expressions related to the Venn diagram expressions of unions and intersections and complements in this particular fashion. So I will use this concept and simplify what is not A union, not B. So when I say not A union, not B, it basically means that we are looking into intersection of A and B and then excluding that. You get the idea. So let's see, does this make sense or not? This is a very important concept. So let's try to shade and figure this out. When I say not A, it means everything which is outside of A. So I'm saying not A is this, right? Perfect. That is not A. And when I say not B, it means what? It means outside this portion, correct? So everything outside but not inside the common A and B. Do you see that portion? So everything is shaded here except for the intersection of A and B. So these are equivalent. You get the idea. So, what I'm trying to tell you, when we have complements involved, we can simplify the understanding and could have also shaded in this way. So, in short, we could have done like this, right? So, let me just shade this here separately and show you how we could have done this even faster, right? So, we have these two events, A and B, right? And we want to shade in A intersect complement of A union complement of B. So basically, if I could directly do it, it was like this. Do you see that? I mean, everything outside of the intersection. You get the idea. So the only portion which is left for us is this portion in between. You get the idea. So that is what I mean, that exclude intersection of A and B to get union of not A, not B. Very important concept for you to understand. If you understand this, then the rest of the exercise is going to be very simple. Now let us try to do complement of A intersection complement of B. How you could do it? Well, using De Morgan's law, we could actually write this as A union B complement. You get the idea. Not A union B. A union B is everything inside, and not A union B means we're talking about everything outside. You get the idea. So that will be the result of complement of A intersection complement of B. Does it make sense to you? So see how we have used a property which is De Morgan's law and shaded very easily, correct? So here are three test questions for you, which I will like you to shade and then move forward for these Venn diagrams. So we have done 12. Now let's look into the next set of 12, which is kind of based on combination of complements of the events. Perfect. I would like you to pause the video now and answer these questions. Some of them have been repeated just to see whether you have understood our page which we just completed or not. So treat this as a test. So that is a test for you. In case you have any difficulty, you can always write me back. Now let me show you that some of them can be done very easily using De Morgan's theorem, as we just worked on this. When I say union of not A, not B, I could actually write this as intersection of B with complement. So that is one and the same thing. What it means really is not the intersection of A and B, and therefore I'm going to shade everything outside the intersection of A and B. You see how easy it becomes? So I'm trying to summarize the learnings of our earlier lesson. You get the idea. So not intersection of A and B. That is how you could actually complete this particular page. Clear? Now let us take examples where there are three events. So if there are three events, which in this case happen to be A, B, and C, you will have three circles overlapping as shown here. Now, I have actually written each region here just to identify the portions and communicate better with you. Now, let's see how do we do the first one, which is A intersection B union C. Now, when I say union C, that means everything in C is definitely included, right? So I'm going to shade the portion in C first. So C is included, right? So I'm just shading this portion first. So that is what we get. You get the idea. I've written some numbers within C that is going to help us communicate. So all these regions are actually covered, which as far as numbers written is 2, 5, 6, and 8. So we get these number 2, 5, 6, and 8, which is within the shaded portion. And now with this union done, we are now looking into what is in the intersection of A and B, but not yet covered. So as you can see, in the intersection of A and B is region 7, right? So we'll include that 7 also and shade that portion also. You get the idea. So whatever I have shaded now includes intersection of A and B. You could go the other way. You could shade this first, right? And then C. But anyway, in doing all this, regions shaded will be 7, 2, 5, 6, and 8. This makes sense to you. Correct? So that is how you should be doing this particular question. I would like you to answer the others. Let me take one more example. Okay, so this time we will use the concept of complements. So let's take the one which is C for us. So we want to do not A intersection, not B union C. So I'm trying to answer this question, which is not A intersection, not B union C, right? So using De Morgan's theorem, I could write this portion as a complement of A union B, right? So this is same as A union B complement union C. You get the idea. So everything outside A and B and everything inside C, that is what it is. So well, everything inside C, again, I will take this portion which is inside C for me, right? And everything outside A union B, that means this portion. Is that clear to me? How about you? Is this concept clear to you? So, so that is how we have to shade it. Do you see this? Everything outside A and B. So using De Morgan's theorem, it becomes a bit easier for us. So all the regions except 3, 7 and 4 have been shaded. You get the idea. So that is how we'll do part C of this particular question. Perfect. Now here is the last question which I am leaving you as a test example. So we'll apply the De Morgan's theorem. So here is the theorem for you, which is also considered as a law, basically. A union B complement can be written as intersection of not A and not B. And A intersection B complement is written as union of complements of A and B. You can verify this using the event where event A has sets 2, 3 elements of the set as 2, 3, 5, and 7. B is 3, 4, 5, 6, and 7. And C as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Correct? So verify, for example, will be what is A union B complement? We say it is not A intersection, not B. So first you find what is A union B and what is not included in A union B, right? So the whole set here is these numbers, right? You can always write down these numbers and make your Venn diagram. So let's try to do it. Okay, so let me just make one here for you. So we have two events. As far as the numbers are given to us, the universal set U has numbers from 1, 2, 3, 4, 5, 6, 7, 8, and 9. In A, we have 2, 3, 5, and 7, and in B, we have 3, 4, 5, 6, and 7. As you see, common elements in both A and B are what? Well, we can identify 3 as common, right? We can identify 5 as common and also 7 as common. So we can write these elements in the common portion, which is 3, 5, and 7. So we have 3, 5, and 7 here. Now left with 2 on A side, and in the B side of the event, we are left with 4 and 6. Numbers which are not included here will go outside. So we have 1, 2, 3, 4, 5, 6, 7 are there inside, and then here we have 8 and 9. Do you see that portion? So that is how we can actually form our set. And now you can verify the result. Is that clear to you? So what is A union B? A union B complement. What is not included in union means everything outside, means it should be 1, 8 and 9. So this is basically equal to 1, 8 and 9. Do you get the same result when you do not A and not B intersection? Means outside both A and B? Yes, you do. Do you see that? So that is how we could verify the Morgan's law. You can use this and do part B, correct? Now, extended portion of our file is try to prove De Morgan's law. You can always watch my videos to understand, and if you have a difficulty, send an email on the address given. Check our website for more details. I hope it makes sense. So in today's lesson, we have seen in details how do we really work with Venn diagrams? How can we simplify when a lot of complements are involved? So not and not means A. You get the idea. So, negative of negative is positive. That concept is brought up by De Morgan's law, which we utilize to fill in the Venn diagrams as required. I hope you find it interesting and useful. With this, we come to an end of this worksheet solution. I hope it means a lot for you. In case you want to learn from me, you can always register by sending an email on the address given. I can be part of your success story, build strong foundation, and ensure bright future. Thank you.